Okay, in this example, we have 3 people, or your 3 younger siblings, let's say, all pulling on a tray full of Halloween candy. Okay, so here's our tray. We're told that the mass of the tray is 2.5 kilograms. The mass of the tray plus the candy is 2.5 kilograms. And the tray sits on a horizontal kitchen table. Each sibling pulls horizontally on the tray. Okay, so we have the force of Junior pulls due south with a magnitude of 85.0 newtons. And let's say that we're calling, so here's our north, south, east, west, and let's call north positive and east positive. Okay, so this would be west. Okay, so let's call our east-west direction X and our north-south direction Y. Okay, we have Arya pulling with a force of 90 newtons. 90 newtons in a direction 35 degrees north of east. So this is 35 degrees north of east in our reference frame. And we are told that the tray accelerates. Okay, so it has an acceleration due north of 20.0 meters per second squared. Okay, so the question is, how hard and in what direction does a Luis pull on the tray? Okay, so we want to know, we could draw it however we want, but we can kind of look at it and realize if it's accelerating to the north, okay, it's probably going to be, and there's no acceleration in the X, Luis is probably going to be pulling in this direction somehow. Okay, so again, we're going to break things into components. So force of the Luis in the X direction is going to be here. Force of Luis in the Y direction will be pointed up like that. And we will want to solve for the FL, force of Luis, that magnitude and that direction theta. So that's what we're trying to find. Okay. So the first thing we want to do in problems like this, we want to split things into their components. So split vector the forces into their components on our X and Y direction in our reference frame. Okay, so we have so I've already split Luis into his force in the Y direction, force in the X direction. Let's go ahead and split this 90 Newton force, which is force of Arya, into its X and Y components. So force of Arya in the X is going to equal 90 cosine 35. And then Arya's force in the Y direction is going to equal 90 sine 35. Okay, and the force of Junior is just in the Y direction. Okay, pulls due south, so there's no X component. Okay, so now that we've split our forces into their components, let's go ahead and write Newton's second law. And we're going to write Newton's second law, sum of the forces in the X direction equals mass times AX. So we're going to write Newton's law for the X direction. And then let's also write Newton's law for the Y direction. So sum of the forces in the Y equals the object's mass times its acceleration in the Y. Okay, so there we have Newton's second law written in component form. We don't have a third dimension here, so we just need the X and Y. We do know that there is an acceleration in the Y direction. We know that this is going to be 20.0 meters per second squared, and we know the mass is 2.50 kilograms. Okay, and we also actually know there is no acceleration in the X direction. That net acceleration of the tray is just in the Y direction, so we know since AX is 0, that Newton's second law is going to be the sum of the forces equals 0 in that X direction. Okay, so now let's write down our forces in the x direction, and we know that they must equal 0. So we have, here's an x direction force, and we also have here Luis produces some force in the x direction. So we have 90 cosine 35, and that's in our positive x direction. Okay, and then let's just write, okay, we know there's plus force of Luis in the x, and that all is going to equal 0. Okay, I could look at my picture, and I'm anticipating that force of Luis in the x direction is going to be negative. But if I write a plus sign here, if it indeed needs to be in the negative direction, my answer will be negative. And sure enough, I get FLX is negative 90 cosine 35. Okay, so I have just solved for Luis's x component of his force. Okay, now let's look and see if we can figure out that y component using Newton's second law. So if we look at the y, we have force Luis in the y, we have force of Junior in the y, and we also have a force of Aria in the y. Okay, so we have 3 forces acting in the y direction. Okay, FLY plus 90 sine 35. Okay, and minus 85. And that's going to equal, I'm going to have to scroll over here, that's going to equal 2.5 kilograms times 20.0 meters per second squared. Okay. So the sum of the forces is going to equal, we know the sum of all of these is going to equal, well, I'll just do it up here. So 2.5 times 20, that's going to be 50 newtons, right? Okay, so we have 50 newtons there, and we can subtract our 90 sine 35. So we got 50 minus 90 sine 35. And then we add 85 to both sides, so plus 85. Okay, so we have the force of Luis in the y direction is going to equal 135 minus 90 sine 35. So FLY. Okay, fantastic. So now we know what those 2 components are of Luis's force. Okay, so it's in the x is in the negative x direction, and so it's pointed to the west, and the magnitude of that is 90 cosine 35. We've drawn our arrow to the left, so we don't have to put the negative sign there. Our force of Luis in the y is going to be 135 minus 90 sine 35. Okay, and I could also just solve for those. Those are just numbers, right? I think this is like 73.7-ish, and the force in the y is 83.4-ish. Okay, but I'm going to keep the exact values until the end all round. Okay, so we want to find the magnitude FL and this angle theta so that we can answer the question given in the problem as to how hard and in what direction does he pull on the tray. Okay, so Pythagorean theorem tells us that the force, the magnitude of the force, is going to equal 90 cosine 35 squared plus 135 minus 90 sine 35 squared. Okay, and we end up getting 111 newtons of force. That is the magnitude, and we can use tangent to figure out that angle. So if we're trying to find that angle, we have to do opposite over adjacent. So 135 minus 90 sine 35 divided by 90 cosine 35. And we get an angle of 48.5. Degrees north of due west, so north of west. Okay, so there is our magnitude and direction of that force. Let's see if we can get the whole problem in the frame. So there is the solution to that 3-person Halloween tug-of-war problem. Okay, here in our second example of a problem that we need to use Newton's second law to solve, we have a pine-scented air freshener hanging from your rear view mirror. And the question is, at what angle from vertical does the air freshener hang when the car is accelerating forward at a constant 5 meters per second squared? So you may have observed something like this in your car before. When you first start to accelerate, it probably hangs a little bit, but at some point, once it's hanging at a constant angle, it will be moving along with the car, so it's going to have the same acceleration as the car. Okay, so we know that this acceleration of the tree and the rearview mirror and your whole car is going to be 5 meters per second, and I forgot my squared. Meters per second squared. So this angle from vertical is we're looking to solve for this angle right there, which we know from geometry, opposite internal angles, those are going to be the same. So that's the same as that angle right there. Okay, so that's the angle we're trying to solve for. So we're not given a lot of information in this problem, right? The only numerical value we're given is that acceleration. So let's go ahead and just try to set up Newton's second law in component form and see if we can cancel some stuff, because things are probably going to need to cancel for us to get an actual value for theta. Okay, so if we draw the free body diagram for our tree here, okay, well, we have the force of gravity acting downward, and that force of gravity is going to be equal to the mass of the pine-scented, so we'll put pine-scented air freshener, so we'll just subscript P, times 9.8. That's going to be the force of gravity acting downward, which, you know, we could draw the center mass of this and draw it in this diagram as well, but we don't need to. But there is also a force of tension acting on it up towards the rearview mirror, so through that lightweight thread that it's connected to the rearview mirror with. So we also have this force of tension here. Okay, and that force of tension is going to be that angle that we're looking for, theta. And let's draw the angle with respect to vertical, because that's the angle that we're trying to find. Okay, so here's our free body diagram. But let's go ahead and, these are not, like, we need to put a reference frame with our free body diagram and establish which direction we want to be the positive direction. So let's go ahead and call upward the positive y direction, and to the right the positive x direction. So that means we're going to need to split this force of tension into its horizontal component here, ftx, and its vertical component here, fty. Okay, and both of these, ftx and fty, oh, and remember that if that angle is theta, then this angle is theta right there as well. So ftx in terms of theta is going to equal the tension force times the sine of that angle, because we're opposite, so sine theta, and fty is going to equal ft cosine theta, okay, because it's adjacent to that angle. Okay, and I also could have drawn these vectors over here as well. I just had my theta labeled, so I could have drawn them on the other side as well. Okay, so now we have all our forces that we know of that are acting on this, this air freshener. And let's set up Newton's second law. Okay, so Newton's second law tells us that this vector sum of the forces are going to equal the object's mass times its acceleration. Okay, so we'll split that into its vector components. So the sum of the forces in the x is going to equal the mass of that air freshener times the acceleration in the x. Okay, and I'm going to scroll over a little bit here. And our sum of our forces in the y direction are going to equal, okay, the mass times acceleration in the y. But we don't have any acceleration in the y. That's just 0. So we know our sum of the forces in the y direction are going to equal 0. Okay, let's write out what forces we have. So in the x direction, really all we have is our ftx, right? So ftx equals mpax. And let's write ftx out with what we know. ft sine theta equals mpax. Okay, so we don't know the mass and we don't know the tension, the force of tension. We do know the acceleration. Okay, let's go ahead and write down what we know in the y. See if that'll help us at all. Because right here we can't solve for anything yet because we don't know the tension. It's an unknown, and the mass is also an unknown. Okay, but maybe the second law for the y direction will be helpful. So in the y direction, we have fty and fg. So fty is in our positively established y direction minus fg equals 0. So we know fty is going to equal fg. And we know a little bit more. We know Fg is the mass times little g, which is 9.8. And Fty we know to be Ft cosine theta. Okay, so now we have two equations. What if, and two unknowns. Well, we actually have three unknowns. But I might be able to get something to cancel. So what I'm going to do is I'm going to solve this equation for Ft and then plug that in to here. Okay, so let's go ahead and solve this for Ft. Okay, so I get, it's going to equal, for the tension force is going to equal the mass of the air freshener times g divided by cosine theta. So let's plug that in for force of tension over here. Okay, well, we might be getting somewhere here because this cancels, and then I get g, and then sine theta over cosine theta, we actually know from trig identities, is going to equal the tangent. Okay, so we get g tan theta equals ax. And folks, we know ax, we know g, so we are able to solve for theta. Okay, so we know the tangent of that angle is going to equal the acceleration in the x direction divided by 9.8. So theta is going to equal the inverse tangent of ax over g, which is 5.00 divided by 9.80. And we get an angle of 27.0 degrees. Okay, so that is going to be our angle with respect to the vertical that that air freshener is hanging at. Okay, so one interesting thing that kind of happened here was that the mass is not important. So regardless of the mass of that object you had hanging from your rear view mirror, the angle would be the same. which is kind of a cool result. And we did have 3 knowns, but what I noticed here was that there was an MP here and an MP here, and if I substituted in, I could get one term and end up canceling the masses. Okay, so that's why it's independent of the mass, because regardless if the mass was 5 or 5 kilograms or the mass was 1 kilogram, if you have it on both sides of the equation here, that is going to cancel. Okay, so that is the second example I have for you of using Newton's second law to kind of solve a problem here.